Hi there, what's up? Welcome back to Economics. I am Dr. Shreya Roy, and in today's lecture, we are going to be learning skewness and kurtosis, which are a very important part of data analytics. This helps you to understand how is the data distributed about its mean median mode. If you still haven't watched our mean median mode central tendency video or the lectures, please go ahead and do that before watching this one. I'll link them up in the iCard or down in the description box. So Economics is an international education, research, and data analytics company. This is a online certificate course of data analytics using SPSS. If you want to register to this course, the details are down in the description box. Go and hit the link. So basically, you can watch the videos for free, no issues with that. But once you are ready and prepared, please fill up the form and take up the examination. Once you have cleared the examination, we will give you an international and Government of India recognized certificate stating that you have successfully cleared SPSS, the data analytics certification course. About Economics is registered under Ministry of Corporate Affairs, Ministry of Education, Ministry of Commerce and Industry, that is Startup India, MSME, and Skill India. I think that's about it. Let's roll into the video. Initially, I'm going to be briefing you up about skewness and kurtosis, and then we are going to be heading to the software to understand how to interpret the results and how to analyze data for skewness and kurtosis. Also, a very important thing, if you want the notes and the handouts, please write to us at contact@economics.com, or the WhatsApp contact number is being displayed on your screen. Or you may also drop a comment down below. However, just a heads up, YouTube is not my forte. We, or at least personally, I do not keep a track of the comments on the YouTube. So I highly request you, please drop a message on WhatsApp or email me. We reply to each and every email and WhatsApp regularly. Okay, so skewness and kurtosis. Let's begin with skewness. So skewness measures the asymmetry of the probability distribution. Let's say that there is a data. Data is mostly displayed in inverted U format. Okay, so if you can keep a mirror in the middle, if the left-hand side is equal to the right-hand side, you say it is perfect distribution. However, that is a very rare case and does not hold true with real life data. So skewness measures the asymmetry of the data. Now, there are three types of skewness. First is positively skewed, second is negatively skewed, and third is zero skewness. Now, let's understand positively skewedness. So a right skewness is also called as a positive skewness. What does this mean? This means that the data, the extreme data, the larger values of the data are mostly distributed on the right-hand side. So we say that the positive skewed has a right tail. Okay, so there are more data or heavier data on the right side, or we can say that the mean is greater than the median and the mode. Okay, so the data should look something like this, where if this is my center point, then there are fewer extreme data on my left side and plenty heavier data on my right hand side. Hence, we call it right-tailed data. Okay. On the other hand, there is a negative skewness or left skewness, in which the data are heavier, or the extreme values of the data are more towards the left-hand side, and hence it is a left-tailed data. Okay. So it should look something like this. So if this is my center point, then there are more data on the left-hand side than on my right-hand side. Okay. Here, mean is lesser than my median and mode. Now, skewness, zero skewness is a perfect data in which mean is equal to median is equal to mode, in which if you can keep a mirror in the middle, then the left-hand side is equal to my right-hand side. I hope the theory is, clear, as in what are we trying to understand with this data distribution. Now, let's understand with our software. I'm not really sure how good my data is, but still, let's just create the data. If you haven't watched our previous videos on data entry, data imputation, or opening a data, please go ahead and do that. It's an entire compact course where you're going to learn A to Z about SPSS, data analytics using SPSS, and we are still at the very starting part of it. And the later stages or the later sessions are going to be much more heavier. So these are just the basics. Once you get your hands on, you get easy, with the comfortable with the software, then we can enter into the more hardcore things. Okay. Let's convert them to 0 because we do not have any decimal places. Okay. Now, so these are my 3 data that we are using to understand. What are we going to do? We are going to go to Analyze, Descriptive Statistics, Frequencies, select A, Statistics. Over here, we are going to click on Skewness, click on Continue, click on OK. So we see that it is a positive value, which is 0.887, or we can simply say 0.9. So it's a positively skewed, which means it is heavier with extreme values on the right-hand side of the entire data plot. Okay, so mean is greater than median and mode. Now, similarly, let's go to Analyze, Descriptive Statistics, Frequencies. Now, I want to reset because I want all of them together, okay? So I'm resetting, bringing it back to normal, then clicking on A, B, okay, C, B, and then going to Statistics, clicking on Skewness, clicking on Continue, clicking on OK. Now, the output result that I got is this, in which we see A is positively skewed, C is zero skewed, and B is negatively skewed. So this displays all the 3 types of our skewness: positive or right-tailed, zero or exact mirror with no biasness, and negative or the left-tailed. So we have witnessed all the 3 types of data here. Now, let's quickly move to kurtosis. So kurtosis is a statistical measure that describes the shape and peakedness of a probability distribution. It measures the degree of heaviness in the tails and the sharpness of the peak relative to normal distribution. So a data, if U-shaped, can be very peaked or flat. So it can be peaked or flat, whereas normal distribution is a standard distribution. It can be lipokurtic, it can be mesokurtic, or it can be platykurtic. Now, lipokurtic is greater than 0, mesokurtic is equal to 0, and platykurtic is less than 0. Okay? So, in lipokurtic, the tails are heavier. Okay? The peak is sharper than the normal distribution. So basically, it has a very steep slope. That is called as leptokurtic. Okay? Now, for mesokurtic, it is basically same as the normal distribution. The tails are neither too heavy nor too light, and the peak is neither too sharp nor too flat. On the other hand, we have platykurtic, in which the tails are lighter and the peak is flatter. So basically, if it is something like this, more flat and lying on the axis, then we call it as a platykurtic. Okay, and it should be less than 0. Let's take a look quickly. Okay, when the peak is high, we call it leptokurtic. When the peak is flat, we call it platykurtic. And a very normal distribution is called mesokurtic. Okay, let's quickly understand with some practice data. Okay, we'll quickly run through this data itself and see what we are getting. So analyze descriptive statistics, frequencies, click on statistics, and also click on kurtosis, click on continue, click on OK. All right. Okay, so for the given data which we were using to understand skewness, we see A is a negative, C is also negative, B is positive, which means A and C are platykurtic and B is leptokurtic. Okay, so we do not have a mesokurtic. Now let's quickly type another set of data to see. So this is my given data. Now let's quickly see if we can get, all the three types of kurtosis or not. So I'm not very hopeful. Let's see. Descriptive statistics, analyze descriptive statistics, frequencies, reset, D, E, X, statistics, click on kurtosis, continue, okay. Okay, now we have all of them as negative values. Not something I was looking for. Okay, that's about it. I couldn't give you some valid data in which we could show all the three types of kurtosis, but I think that's okay. You get the point. That is how it is calculated, and there's nothing I could do more about it. I have to create more data. Probably I'll drop an example down in the description or in the comments in the days to come, so you can try out to display the positive, negative, and the 0 for yourself. However, I could not get a data set which would display positive, negative, and 0 for you. I think that's about it. Thank you for watching. I'm a little disappointed, however. So if you liked it, like and subscribe, and see you in the next session. Until then, bye.